example, we are going to graph the given function. So they gave us a function here. This is a quadratic equation in vertex form. So to go from a quadratic equation that's in vertex form to graph, first thing we want to pay attention to your sign here in front. Is it positive? Is it negative? Keep in mind a positive parabola looks like this. It opens upwards. Negative parabola has this general shape right here. So we are looking at a positive version. We know this is going to open up. Your starting point of your graph is going to come from HK, this part of your equation right over here. Again, vertex form of a quadratic looks like this. HK is the vertex. So these two numbers here, mirror them up with your equation. RHK, which is the vertex of our parabola, is a positive 6, positive 4. Again, pull this number, opposite sign. So instead of a minus 6, we want a plus 6. The number on the outside, that exact number. This is a positive 4, we want a positive 4. So positive 6, positive 4 is what we're going to pull here. That's your first point. Go ahead and plot it. Go over 6, up 4. That's the vertex. So this already gives us a lot of good information here. We know this is where our graph starts, and it's going to go upward from here. It's going to shoot upward from this point. So that already tells us a lot from here. Now, in order to graph a quadratic in vertex form, you typically need a minimum of 3 points. We already have 1. The great thing about a parabola is if you cut a parabola right down the middle, it is symmetrical. Everything on the left matches up with everything on the right. If we folded it on this line, again, everything would merge nice and pretty. What that means for us is that if we find a point over here on the right, we can just mirror it right over here, a point on the left. So that's exactly what I'm going to do here. So I know my starting point. I just need to figure out what the next 2 points over here on either side is. So what I'm going to do is I'm going to go 1 point to the right, right? So since this point here is a 6, I'm going to look at what's happening when x is 7. And I'm just going to go old school here. I'm going to do an XY table, and I'm just going to plug in 7 into my table, plug it into my equation to see what that y value is and get that point. So I'm going to take this equation, and I'm going to plug in 7 into x. Simplify this. Well, 7 minus 6 is a 1. 1 squared is just 1, which really just gives us 4 times 1. So I'm left with 4 plus 4, which is 8, which tells us I now have the point 7. Well, let me see here. 7, 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. I can go ahead and plot that. 7, 8. So from the vertex, when I went over 1, up 7 for that next point, right? So that means from the left, I can go to the left 1, up 7 for that point. So from the vertex, again, the vertex was 6, 4. I went to the right 1, and I looked at what 7 was doing there. I plugged in 7 to the equation, got 7, 8. So from this point, over 1, go up to the 8, which means we can also mirror on the left, go over 1, go up to the 8, since we do know that quadratics are symmetrical. This is what our graph would look like.